Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about this idea, which is goodness of fit test. So basically, in this test, you are interested to see or to test the following null hypothesis. And in general, the null hypothesis can be written as such. The observed frequencies for an experiment. So this phrase here represent your data. So this is basically your data. Follow a certain pattern or theoretical distribution. In general, this is how you can write your null hypothesis. Now, when you talk about pattern or theoretical distribution, you can be specific and change this word with, for example, is it a normal distribution, is it a binomial distribution, or Poisson distribution, and this all depends on the example or the question asked. Okay, right. Now, given the above null hypothesis, what do you think is the alternative hypothesis? And as you have seen before, the alternative hypothesis is just a contradictory statement of the null hypothesis. So, in other words, or in general, this is what you can write. You can say that the observed frequencies for an experiment do not follow a certain pattern or theoretical distribution. So this is in general what you can write as your alternative hypothesis, and maybe for a better understanding, you will have to refer to the example which I'm going to give in the next video, okay? Right, now in other words, the idea of goodness of fit test is very simple. It is just to see how good the observed frequencies or how good the data is and how well they fit a given pattern. Or in other words, you would like to measure or you would like to check if your sample data represents the data you would expect to find in the actual population. Or simply said, you want to see your data versus, I'm sorry. So in other words, you would like to see the comparison between your data versus expected data that you expect to see, okay? You want to compare what you are seeing with what you expect to see, okay? Right, now these are the terms that you should be familiar with: observed frequencies and expected frequencies. And I'm just going to illustrate the ideas here using this simple example. Let's say in an experiment of rolling a die for 1000 times. So you can imagine one person is just tossing a die for 1000 times, and the interest may be to test the null hypothesis that a given die is fair. So here is a statement that shows some sort of pattern or theoretical idea. And so this becomes your null hypothesis. Now, in doing that, you need to be able to observe the frequencies of getting 1 dot, 2 dots, 3 dots, 4, 5, and 6 dots. So you will be observing how many times you get 1 dot or how many times you get 6 dots. And this is called observed frequencies. And this comes right from your sample. And this is your data. All right, and in general, the notation used is O. So O here represents the observed frequency. Your observed frequency here will be compared with the expected frequencies. And expected frequencies is literally related to the frequencies that you expect to get if the null hypothesis is true, or if the given die is fair, what would be the frequencies you might expect? to get, and it is denoted by E. So E here represents the expected frequency. Okay, let me just give you a simple example. So let's say that you toss a die 6 times, and if the die is fair, what would be the number of frequencies that you get? So what would be the frequencies that you can observe? For example, what would be the frequencies that you will observe, or that you expect, okay, that you expect to observe when the die is fair? So when the die is fair, if the die is fair, you toss the die for 6 times, what would be the frequencies that you expect to observe? So if I say this is a categorical data, you get 1 dot, 2 dots, 3 dots, 4, 5, 6. And therefore, if the die is fair, you will expect that the probability of getting 1, 2, 3, 4, 5, 6 must be equal to 1 over 6. And if you toss a die 6 times, you will expect to get 1 observation for each category. So this is expected result. And let's say if the die is fair and you toss the die 12 times. If you toss the die 12 times, then the expected value that you will get in this circumstance is, so if you toss the dice 12 times, the expected frequency that you expect to observe will be 2, 2, 2, 2, 2, and 2. So it will be, the total is going to be equal to 12. Okay, and for this one here, total is 6. And therefore, if you toss the die 1000 times, then the expected result that you will get, would be 1000 over 6. So 1000 times 1 over 6 basically. So here is the same thing, 1000 over 6, 1000 over 6, blah blah blah, the same value for each category. Okay, so 1000 over 6. And this is the expected frequency if the die is fair, because when the die is fair, the probability is going to be 1 over 6. And if you toss it for a number of times, this will be multiplied to the probability in order to get the expected frequency. And therefore, this is a formula that you will have to implement in order to find the expected frequency. N is the sample size and P is the probability of belonging in a particular category. Right. Now, to test the hypothesis, you can follow the general procedure outlined in Chapter 3 and Chapter 2, which is hypothesis testing. Okay, and it is either using the traditional approach or p-value approach. Why are we using traditional approach or p-value approach? This is because the test is always right tail. So this is a one-sided test. So when you have a one-sided test, you can only use either p-value or traditional approach. You cannot use the confidence interval approach. Yeah. Now, in order to apply the test, goodness of fit test, this is a requirement. The expected frequency for each category has to be at least 5. So you must check whether this is true or not, and if this is not fulfilled, the test should not be executed. And the next one is the statistical test to be used in the hypothesis testing is given by this formula here. Basically, this is the summation of observed minus expected, and you square it. Observed value minus expected value, square it, and you divided that with the expected. value. The degrees of freedom for goodness of fit test is this one, k minus 1. So k here is the number of possible outcomes in a multinomial experiment, or in a simple word, k here is the number of categories that you have. Okay, so here degree of freedom here is required when you want to refer to the chi-square distribution table. Now if you look at the problem given here, so if we look at this problem, what we can see is, based on this example here, you can write down your null hypothesis as such. We can say that a die is fair, and the alternative hypothesis is a die is not fair. Okay, and therefore, since the null hypothesis is related to a die being fair, a die is fair if the probability of getting 1 dot, 2 dots, 3 dots, blah blah blah, and 6 dots is equal, which is 1/6. And based on this probability, and based on the number of times you repeat the process, you will be able to find the expected frequency based on this formula. So E is equal to N times P. Okay, I think that's all for now. Thank you very much for watching.